The last one that I'm getting some questions about is question 5.44 from the homework. When 100 grams of zinc combines with 60 milliliters of HCl in a calorimeter, all the zinc reacts, increasing the temperature of the HCl solution, aqueous solution, so water-based solution, from 23 degrees to 25 degrees. Sure, given the following equation, we don't really need to use the following equation, but calculate the enthalpy change of the reaction in joules per mole. And now here's the important part. Assume the volume of the solution doesn't change, so 60 milliliters. And yes, it's an aqueous HCl solution, but for the purpose of this experiment and this calculation, the specific heat is going to be the specific heat of water because it's an aqueous-based solution. And so the water is the majority of that solution. It's just very little HCl in there. So I need to find the heat the energy that the water absorbed, and that would be the heat that was produced when zinc reacted with HCl. Before I do that, though, I need to convert the 60 milliliters into grams, knowing that the density of water is 1 gram per milliliter. So 60 milliliters would be 60 grams of water, and now I can find the heat that the water absorbed to go from 23 degrees to 25 degrees, right? So 60 grams of water, the specific heat of water is 4.184 joules per gram times degrees Celsius, and I go through a temperature change of 2 degrees Celsius. So the calorimeter, right, the water in the calorimeter absorbed about 502 joules of energy. And in order for the calorimeter to absorb 502 joules of energy, right, the heat of the calorimeter is the opposite of the heat of the reaction. So because the calorimeter absorbed this energy, the reaction must have released this energy. So the Q of this zinc reaction should be negative 502 joules. So now I know how much heat was released when 0.1 grams of zinc reacted. Now to find joules per mole, I just need to find out how many moles of zinc were in this reaction. So I've got 0.1 grams of zinc. I go to the periodic table. The atomic weight of zinc is 65.38, so molar weight of zinc would be 65.38 grams per mole. So approximately 0.001529 moles of zinc. And now the last step, right, joules per mole. So literally divide, find the delta H of the reaction, right? 502 joules of energy were released when 0.001529 moles of zinc reacted to produce delta H of the reaction in the order of 3.28 e to the 5, and that should be joules per mole. So hopefully that helps with question 44.